and then I'll press my share screen. So let's get that on full screen. Okay, there we go. So can you all see that okay? Good. All right then. So I think you will know, but perhaps other people that will watch this later may not know that I'm Faye Padicchia. I'm the Trust Maths lead, and this is the Year 2 Maths workshop for parents. Okay, so look at the next slide. So we are going to consider, what will my child learn about? What does my child learn? Sorry, how does my child learn maths at Castlemead School, and how can I support my child to be successful at maths? So I've got this little image here that shows the 3 aspects of maths. So maths is made out of these 3 areas, and the first that most people are familiar with is about computational procedural skills. So that's about how you work things out. It's about learning all the number facts, and lots of people think that that's what maths is, but there is more to it. So it's really important that what we need to do is to make sure that children have a good understanding of the concept behind what they do with those numbers. So that's a big shift in things, and then applying what they're learning to solve problems. So you'll see that reflected in the national curriculum aims. So the first one is to become fluent in the fundamentals of maths. So that relates to that computational aspect. Reason mathematically, and so that's about bringing what they know together and then solving problems at the end. So, and in order for children to be able to reason mathematically, they need to really understand those concepts really deeply. They need to understand and be able to use mathematical language accurately, and they need to know links between different areas of maths really well. So making connections between areas will help children to have the depth of understanding that we want for them. So in Key Stage 1, the national curriculum puts years 1 and 2 together. So the objectives are that they should develop confidence and mental fluency with whole numbers. I can't see that, counting and place value. Okay, and this should involve working with numerals, words, and the 4 operations, and by that we mean addition, subtraction, multiplication and division, and using practical resources. So, and one of the ways that we really want children to learn their maths now is through the use of physical materials, but that's not just in Key Stage 1, it goes all the way through, but you'll see less and less of it as children secure their basic understanding of the underlying concepts in maths. The second point is that they should develop their ability to recognise, draw, compare and sort different shapes and use the related vocabulary. They should involve using a range of measures to describe and compare different quantities such as length, mass, capacity, volume, time and money. I've missed one out on the screen actually. There's another one there, which is to know their number bonds to 20 and be precise in using and understanding place value. And an emphasis on practice at this early stage will aid fluency. So when we say number bonds, we mean the pairs of numbers that go together. So if we're talking about number bonds to 20, we mean the pairs of numbers that go together to make 20. So children in Year 2 really need to know those if they're going to succeed. And as with any stage in learning, you'll get children that know those facts really, really well, and there'll be other children that know more facts. They'll be learning their number bonds to 100, and then there'll be other children who will still be working on their number bonds to 10. But what they're aiming for in Year 2 is to know those number bonds to 20. And I also mentioned place value. So we're talking about the value of each digit in a number. That's really important. So understanding hundreds, tens and ones. And then the last point that I have there is read and spell mathematical vocabulary at a level consistent with their increasing word reading and spelling knowledge at Key Stage 1. So we're not being unreasonable. We're teaching them particular language so that they can express themselves accurately when they're describing what they're doing with their maths or what they can see others doing. So that they're exploring, developing their understanding further. That's really important. So
can I just jump in a minute?
Yes, please.
Oh no, sorry, I've just had a message from another mum saying she's trying to get in.
Oh. Perhaps if I unshare my screen a moment.
Jane.
I can't see anything there, but let's just have a look.
It says it's going round in circles for some reason.
So it's buffering. I can't see that. I think I'll just have to carry on, and then if she can't get through, then she'll just have to see the recording. There's nothing visible to me. I'm really sorry. If you can pass on my apologies,
I'll tell her there'll be a recording,
but I'll keep an eye out, and so if she does come through, then I'll let her in. Okay, if you can pass that on, thank you. Let's remember that. So I was saying that the curriculum in Year 2 is divided into 7 strands, as it is with other year groups. So you've got place value, addition and subtraction, multiplication and division, fractions, measurement, properties of shape, position and direction, and statistics. So by statistics we mean things related to data collection, and how you represent that primarily in charts and graphs, and then being able to understand what a chart or graph is telling you, what information it's conveying. Okay. I want to change the page and it's not moving, so I'm having problems now. Oh, there we go. So, how does my child learn maths at Carson Reed School? So we use something called the mastery approach. Oh no, there we go. And this means that maths is achievable for all. So we've got high expectations and encourage a positive can-do mindset towards maths in all pupils, regardless of their confidence level. And we try to create learning experiences which develop their resilience in the face of a challenge, and carefully scaffolding learning so that everyone can make progress. So I think the positive mindset is so important, and I can't really emphasize that too much. And I would say that even if you feel that maths is not an area that you feel confident with, try not to pass that on to your children, try not to convey that to your children. Try to always talk about maths in a positive way. And also that resilience in the face of a challenge that I mentioned, that's also really important, that children develop that sort of stickability, that they don't give up when they see that something's hard, that they keep on trying. So it's an attitude really that we need to foster in them to help them to be successful, particularly with the problem solving aspect. So they perhaps learn the procedure, but then they're presented with a problem and they really need to be able to sit there and think, well, how am I going to use what I know to solve this problem? The next aspect is that the learning should be deep and sustainable. So lessons are designed with careful small steps, questions and tasks in place to ensure that the learning isn't superficial. That depth is just so important. And then that it builds on previous learning. So that each year the children will learn about similar kinds of things. You've seen that there are those 7 aspects of learning, so they are the same for every year group. The only difference is that in year 1 there isn't any statistics. So year on year children are learning about the same kinds of things but building on to what they already know. We're teaching them to learn to reason about a concept and make connections, and I mentioned that earlier. So that making the connections will really help them to develop a deep understanding and to spot patterns between the different concepts that they're learning about. I've also mentioned about using precise mathematical language, so teaching children about accurate mathematical language is a key feature of what we do. And the idea of that then is that if they can articulate themselves using that language, then it frees up their working memory. Oh, here's another parent. And then that enables them. So the working memory is all about what you're holding in your head at any given moment. So if you don't have to think too hard about what language you're going to use to express yourself, or a timed table fact, then that frees up your mind so that you can concentrate on the more challenging task. So that's really important. Children develop conceptual and procedural fluency. So teachers move through maths from one context to another using objects, pictorial representations, equations, and word problems. So there are high expectations for pupils to learn their times tables. So in year 2, children by the end of the year need to know their 2, 5, and 10 times tables, and to be able to count in 3s. It's not quite the same. But the idea is that they should be able to recall those facts automatically without having to count through or work it out, or use some other tool. If it's automatic, then it's freeing up their mind to be able to concentrate on more complicated things. We're also encouraging children to think about whether their method for tackling a given calculation is appropriate, reliable, and efficient. What we don't want is children taking a more complicated approach to something when they could do a calculation very simply in their heads.
She does a lot of the time.
Oh, I don't know who that was, but could you mute yourself, please? And then moving on to problem solving, we've said that that's key. So every lesson, children will be presented with a problem to solve, and that's really what maths is very much about. Prior to 2014, we spent a week on problem solving and then wondered why children couldn't do that. So it's really, really important. And so every single lesson, children have to solve a problem. And a lot of time is spent on reflecting how that problem will be solved, which are the best methods to use to solve that problem. So children's understanding of why something works, so that they truly have an appreciation of what they're doing rather than just learning to repeat routines. And that's, again, what might have happened in the past. You'd give children a page full of equations that were all very similar. And well, really you're not, when a child is thinking mathematically, they need to be thinking creatively. What's the best way to solve this problem? Is that an efficient method? How can I explain how to do that? What language will I use to express that? That's a far deeper and more sophisticated understanding of what they're doing. And then finally, challenge through greater depth. So rather than accelerating the content and moving children on to the next year's concepts, what we do is to deepen children's knowledge and improve their reasoning skills within the objectives of their year group. Okay. So one of the parts of the mastery approach is the CPA approach. So the C refers to concrete. So that's providing children with objects and resources to manipulate so that they can use that to explore and express their understanding. And then from there, they naturally move on to representing those objects in diagrams, images, drawings and models. And then finally, they're able to use signs, symbols and digits to show what they're doing as, you know, using those things that we're familiar with, so the standard representations. And the CPA approach is very much a recognised way that children learn maths. And we all use these approaches at times, you know, even as adults, we might count things on our fingers sometimes, or if we're a bit flummoxed by something, we might need to draw it out to help us understand more clearly what it is that we're doing or what we want to achieve. So it's recognised as a natural progression in mathematical learning. So here are some examples. So you can see on the left, you've got concrete representation. So you can see different ways of showing numbers, and you might have heard your child talking about part, whole. So in the top left, you've got 7, and part is 4, part is 3. So 7 is made of 4 and 3. But it's then represented in a slightly different way in the right-hand picture. Then in the middle, you've got 10, the whole is 10, and it's made out of 2 parts, 6 and 4. And then finally, you've got 10 with made from 9 and 1. And then you've got pictorial representations in the middle. So a child will learn to draw those part, whole diagrams for themselves. They might represent the objects by drawing them, as in the flowers. And then they'll learn about bar modelling. So you can see that there. So the whole is 5 and it comprises 3 and 2. And then something that looks a little bit more abstract at the bottom. So you've got a bar representing 9 as the whole, and it comprises 8 and 1. And then finally, on the right-hand side, you can see those equations, which are a little bit more like the conventional that we would use. So how can you support your child to be successful at maths? So helping your child to remember number facts, as I mentioned earlier, the number facts, the number bonds to 20 will support them with other more complex and challenging mathematical procedures and concepts. So in year 2, some key things for children to practice are counting forwards and backwards to 100, reading and writing numbers to 100 in numbers and words, number bonds, so those pairs that I mentioned earlier, counting in 2s, 5s and 10s. So you begin year 2 by needing to count, and you would have learnt that in year 1, but by the end of the year you need to know the times tables facts. Recognising odd and even numbers, that's really important. And let's just move this out of the way. Knowing the number that is 10 more or 10 less than any number to 100, and again that builds on in year 1 they needed to know what was 1 more and 1 less, and they also would have practiced that in reception. And with the 10 more, 10 less, it's looking at, well, what stays the same, what's different? So, you know, having those conversations, and you might refer to the 10s and the 1s numbers in that conversation. So top tips for you as parents in supporting your children. So I mentioned earlier about using that positive language and having the positive mindset. So it's really important that you convey to your children as much as you can that, you know, that maths is a positive thing. Try not to, you know, if it is a weakness for you, then try not to show them that. Using maths talk every day, that's really powerful. So it can really have a huge impact on their mathematical development. You might want to start your children off with the basics, so try not to overwhelm them. And whenever you have the opportunity, try to include maths talk. And this is done easily when children are playing with physical objects, and you can reinforce counting skills. So money's a good one in year 2. I think they're either still learning about it. I know they certainly were learning about it last week. And money's quite tricky because you have one object, but it can represent more than one. and children often find that quite tricky. So money is a good one. So how many pennies are you holding, or what shape is that object? So just thinking about, you know, and that they should have quite sophisticated knowledge by year 2 of shapes. They should be learning about, you know, hexagons and octagons, those kinds of things. When counting, reinforce the last number they counted, as this can help their mathematical development further. Again, many of your children may well know those things already. Just like children's TV shows do, you know, just keep reinforcing things. 2 easy concepts to develop are doubling and halving, and they will know about adding, subtracting, and they'll know, you know, most children will know quite confidently about adding and subtracting 1-digit numbers, but looking at 2-digit numbers, that's where they will be, and they will have learnt about that already this year, but it's always good to practice. And also applying that into a sort of a real life context, giving them a reason to practice is good. I've mentioned using physical objects, so using pasta, pegs, dollies, teddies, or Lego's fantastic. So if they were learning about halves and quarters, Lego's really good for that. You might ask your child to count the number of chicken nuggets or peas or any other food on their plate. Or, for example, if I doubled the number of chicken nuggets on your plate right now, how many would you have? If I ate half the peas on your plate, how many would you have? If we added all of my chicken nuggets to your chicken nuggets, how many would we have altogether? Those kinds of just fun things that, you know, it doesn't have to be a big deal, and best not to be a big deal, really. Keep it lighthearted if you can. Memory skills are really important. So one problem that parents often have is that children seem to have little need to memorize things like phone numbers, like you might have done when you were a child. So this might seem like a small thing, but it means that there's an opportunity to practice memory skills that's disappeared. So giving them practice with memorizing things is useful. So maybe practicing memorizing grandparents or best friends' phone numbers and testing them on those occasionally can be a good thing to do. And you could turn that into a game. A lovely game that I've done with children is called Kim's Game. So you have a tray with a few objects on it, maybe 5 or 6 objects, and you put a tea towel or something over the top of it. Well, first of all, let the children look at the objects, then put the tea towel over the top of it, and remove an object, then reveal the remaining objects and ask the child, well, what's missing? So that's a really good memory game to play, and that's quite good fun. You could play that with younger children too, or older ones, in fact. Other memory things that I'm sure you would have done, things like nursery rhymes, a quote from a book or a TV show that they like, all sorts of things. Playing maths games together is a good thing to do, and a lovely way to spend time with your children. Obviously, again, you probably do it anyway, but there are many mathematical and logical skills built into those games that you may not be aware of. So, for example, a jigsaw puzzle helps children to develop logical and spatial awareness skills. Games like snakes and ladders help children with counting the rolls of a dice, but also, you know, what they need to learn is to recognize those numbers on the dice, you know, the dots, and not need to count them. So by now your children should be at that stage, but you might have a game where there are maybe 2 dice that need to be thrown. So just practicing some simple addition that, you know, would arise naturally. Watch out for shapes. So when you look around, everything is made of shapes. So why not encourage your children to learn the names of the shapes when you're out and about, or identifying windows. You might see hexagonal, you know, or more complicated shapes. So we haven't talked about 3-dimensional shapes, but your children will have learnt about cylinders and some simple prisms like triangular prisms or cuboids and cubes and things like that. So keep an eye out for those things. So then finally, I've made a list of useful websites for you. Times Table Rockstars is always a really good one to help your children with their times table. So some of you, you know, whatever your child's ability, Times Table Rockstars is an adaptive program. So it's very much addressed for the individual. So if your child's not so confident with it, it will support them equally. If your child's very confident and they've gone beyond 2 5s and 10s for year 2 and they're working into other times tables, it will be challenging them there. Hit the button if children aren't too keen on Times Table Rockstars. Hit the button is much more standardized. It doesn't record the information, but there's a time aspect to it, so they've got a minute to see how many they can get. But on Hit the Button, there are opportunities to practice those number bonds, like number bonds to 10 to 20 to 100. So if you want your child to practice those things, you'll find that useful. BBC Biteside's very good. Sometimes you might want to support your child, but they're using a particular bit of mathematical language that you're not too confident about. So the Maths Dictionary for Kids could be useful. If you want more challenge for your child, the Enrich website is really good. It's full of really open-ended questions, so there's no limit to the outcomes. So that's really useful. Equally, if your child's not so confident, it means that, you know, there isn't a precise number of answers. So if they only have a couple of responses to a particular problem, that's fine too. You might find the Third Space Learning website really useful. There's lots on there to support you. So I've just listed that one there that's related to the CPA approach, and there's an explanation there for parents. And then finally, I've put Number Blocks there, which is fantastic and really good fun website, which the children absolutely adore. You probably know that already. And I know that goes up to numbers to 100. So if your child's not so confident, that would be really useful. But it's fun for everybody and will just help to reinforce those simple concepts. Okay, so that brings me to the end of the workshop. If I can stop sharing, there we go. So I wonder if anybody has any questions. Okay, I've stunned you into silence. Okay, so right, well, if that's the case, then have a lovely day, everybody. And if you do think of any questions, just don't hesitate to contact the school office with an email, and I'll be very happy to do what I can to support you. All right, thank you very much then. Bye-bye.